Beside determining the order of reaction from the unit of the rate constant, we also can determine the order of reaction from initial rate method, half-life graph, which is graph of concentration versus time, and also linear graph method. Initial rate method. In this method, we have to compare two experiments in which the concentration of one reactant varies and the concentration of the other reactant remains constant. So this is the example of the question. Given 4 experiments with initial concentrations of X and Y and also the initial rate. The question is, what is the order of reaction with respect to X and Y and the overall order? And also write the rate law. So, firstly, we have to write the rate law. That is, rate is equals to K concentration of X to the power of A, concentration of Y to the power of B. Then, to get the value of A, we have to compare two experiments where the concentrations of the Y must remain constant. So that's why we have to compare experiment 4 with experiment 2. Then you calculate the rate of experiment 4 divide with the rate of experiment 2 is equals to this one. Then you will get A is equals to 2. So the reaction is second order with respect to X. Next one, to determine the value of B here, we have to compare experiment 3 with experiment 1 because experiment 3 and experiment 1, the concentration of X remain constant. So you will get B is equals to 1, meaning that the reaction is first order with respect to Y. Then, what is the overall order? The overall order is 3. Then, the rate law is rate is equals to concentration of X to the power of 2 because second order and concentration of Y to the power of 1. But usually, we do not write 1. Second method is graph of half-life. To plot graph of half-life, it is actually concentration of the reactant versus time. So for example here, our initial concentration is 180. So what is the time taken when it becomes half of its initial value? That is 90 molar. So the time taken from 180 molar to becomes 90 molar is 20 minutes. The first half-life is 20 minutes. Then, from this 90 to the power of negative 4 molar to becomes half, that is 45 times 10 to the power of negative 4 molar. The time taken is from here until 40. The time taken is 20 minutes. So now we can see that the half-life remain constant. So what is the conclusion? We can say that the reaction is a first order reaction because the half-life does not depend on the concentration of A or the reactant. Next question. Determine the order of the reaction from this graph of concentration versus time. So what is the order of the reaction? Firstly, the initial concentration is A0, and then when it becomes half of the initial concentration, the time taken is T half. Next, when it becomes half again, so the time taken is called as second half-life. For the second half-life, we can see here the value becomes bigger than the first value. For example, let's say the first half-life is 5 seconds and the second half-life now becomes double, that is 10 seconds. Next, what happened to the third half-life? When third half-life, the time taken is 4 times from the first half-life, that is 20 seconds. So we can see here that the first half-life is 5 seconds, next is 10, and next one is 20, meaning that the half-life becomes double. So what is our conclusion? The reaction is actually second order reaction. The next method is linear graph method. For linear graph method, we have to compare the integrated rate equation with y equals to mx plus c. So, from this zero order formula, a naught minus a is the value of y, k is the value of m, while t time is the value of x. So, the y-axis is a naught minus a, x-axis is time, and the slope is the rate constant or k. For zero order reaction, we will get a straight line graph with a positive slope that starts from the origin. How about first order reaction? For first order reaction, we have to rearrange the integrated rate equation and then compare with y equals to mx plus c, where ln A is the y-axis, negative k is the slope, t is the x-axis, while ln A naught is the y-intercept, c. So when we plot the graph of ln A versus time, we will get a straight line graph with a negative slope with y-intercept ln A naught. Next, second order. For second order also, we have to compare with y equals to mx plus c, where 1 over a is y-axis, 1 over a naught is the y-intercept, and k is the gradient or slope, t is the x-axis. So, when we plot the graph of 1 over a versus time, we will get a straight line graph with a positive slope, and it starts with 1 over a naught as the y-intercept. Let's try an example. The data in table below were obtained from the dimerization of 1,3-butadiene at 600 Kelvin. Use the data above to plot a graph of 1 over concentration of C4H6 against time. Based on the graph, determine the reaction order and also calculate the value of the rate constant. So, when we plot a graph of 1 over concentration versus time, we get a straight line graph with a positive slope that has y-intercept. So now, can you guess what is the order of the reaction? Yes, it is second order reaction. And then, how to calculate the gradient of the graph? To calculate the gradient of the graph, we have to take 2 points at the graph, and then we just write y2 minus y1 over x2 minus x1. So then we will get the answer is 0.87 per molar per minute. The gradient of the graph is actually the value of the rate constant.